Hi guys, and welcome to day 2 of section 3.2, our notes. I am really struggling with my document camera. It's taken me a long time to make these videos, and I'm not really sure that they're actually even that helpful to you. So I'm going to try to get through this. If you need to, if you feel like I'm going too fast and you can't get any of the notes down, remember that you can pause the video. Okay, write what you need and move on. I am going to try to go as fast as I can so that I can try to get the content into the video. So the first thing that we're going to be talking about today is inverse functions. So I just want you to think about what it means for something to be an inverse function. So if you want to pause and think about that, if you have no idea what your answer would be if I was asking you that question, I'll give you the hint that inverse functions are arithmetic functions that are inverses. Addition and subtraction are inverse functions. Multiplication and division are inverse functions. Squaring something and then taking the square root of something, those are inverse functions. Okay, so how would you describe inverse functions? The way that I would describe inverse functions is I would say they are functions that always undo each other. Okay, and the important thing to know, if you are dealing with a table, a graph, or an equation, to get the inverse equation, you can switch your x and y values. Okay, we'll see that later. It's also important to know when you're dealing with graphs, inverses are reflections of each other over the line y equals x. So the line y equals x, that's a line with slope 1 and y-intercept 0, which means it goes through the origin. Finally, some notation that I'm hoping you've seen, but you might not have seen in a while. So this f to the negative 1, that indicates that we're looking at the inverse function of f. So if we take the inverse function at an input of our original function, we're going to get our result is going to be our regular input. And similarly, if we evaluate our original function at its inverse, we will come up with our original input. Okay, if you have questions about what this means, we can go through it during my office hours, okay, or you can send me an email. But I'm hoping that that's familiar from Algebra 2. Okay, the next thing that we're going to talk about before we stopped school a week and a half ago, we were talking about exponential functions. Okay, and we had this parent function. We went from -2 to 2. Okay, and we found these y values by plugging in for x. When we drew our graph, okay, I'm just plotting these points, -2, 1/4, -1, 1/2, 0, 1, and my other points. Okay, hopefully you remember that we had a horizontal asymptote at y equals 0. Okay, and we talked about some important parts of this graph. Okay, so we talked about how the domain was all real numbers. We could put in any number for x. We talked about how the range was from 0 to infinity because it gets closer and closer to 0 at that asymptote but never crosses. We talked about how the intercept is 0, 1, and we talked about how our asymptote is y equals 0. Okay, so this is a time that you probably are going to need to pause and fill in your notes. Okay, so do that if you need to. Again, I'm so sorry about the blurriness. I'm hoping you can follow a lot of our notes. Okay, so how do we find the graph of a logarithmic function? So think about this. This is the equation y equals 2 to the x. And we talked about how this is equivalent to 2 to the y equals x. Okay, and notice how in the equation, the x and the y switched places. Okay, similarly, in the table, all I'm doing here is switching, instead of having -2, 1/4, I switch the x and the y value and get 1/4 -2. Okay, so I'm hoping you can see where those values come from. Then I came down here, I graphed all those values. Okay, so 1/4 -2, 1/2 -1, 1, 0, 2, 1, and 4, 2. Okay, and then I put a smooth curve through these points. So just like we talked about how this is called an exponential curve, this is called a logarithmic curve. Okay, you'll notice for our domain, we don't have any negative x values, and we don't have 0 as an x value. So our domain changes to 0 to infinity. Notice 0 is not included. Our range, we can have any y value. Okay, so our range changes from negative infinity to infinity. Instead of having a y-intercept, we have an x-intercept at 1, 0. Think about that again. They're inverses, so the x's and y's are always changing. Instead of only having a y-intercept, we only have an x-intercept. Okay, in our asymptote, it was horizontal at y equals 0, but now we notice we have a vertical asymptote at x equals 0. Again, the x and the y values switched. Okay, so again, if you need time to go through that, please pause, but I'm going to move on to our next page of notes. Okay, so we want to sketch graphs that involve our parent function. Okay, our parent function here is going to be y equals log base 2 of x. Okay, so we want to see, hopefully you can see your input in your argument. That's changing. Okay, so our new x is changing, but hopefully you can see nothing is happening in terms of our vertical shifts, so our y values are going to stay the same. So I apologize if this notation is a little different, but I think before we started remote learning, I was calling these x0 and y0, and then I looked at my notes, which I am not going to be able to scan again, that I have from last year, and it turns out I called these XP and YP. So I hope that notation doesn't throw you too much. The reason why I used it was for X of the parent function and Y of the parent function. So before vacation, or not vacation, but before we started remote learning, we were using, or it might actually been before vacation, we were using X sub 0 and Y sub 0. Now we want to use X sub P and Y sub P as the parent values. Okay, so this is my YP is going to be log base 2 of my X sub P. And from the opposite side that we already found, I can find my notes, we knew that the parent function was 1/4, 1/2, 1, 2, and 4. And the y values were -2, 1, 0, 1, and 2. Excuse me. So we talked about how the new y is the same as the old y. There are no vertical transformations in this graph. So I'm just going to copy down those values. Okay, but we also talked about how our XP, our input, our argument, has now changed to x plus 2. So solving for x, I'm going to have that x is equal to xp, the parent x, minus 2. Okay, I'm going to start with my integer numbers. They're easier. 4 minus 2 is 2. 2 minus 2 is 0. 1 minus 2 is -1. Putting this in terms, I'm going to have 1/2. 2 is 4/2. So I'm going to have -3/2. And then I'm going to have 1/4 minus 2 is 8/4. So I have -7/4. Okay, and I also want to think my old asymptote occurred at xp equals 0. So my new asymptote, my x is going to be 0 minus 2, which is negative 2. And if we think about that, this makes sense. This is a graph that's going to be shifted 2 units to the left. So I'm going to draw in my vertical asymptote. And then I'm going to draw in some of my other points. Negative 7/4 is going to be close to negative 2. And I'm going to go down 2. Negative 3/2 will be about negative 1.5. And up to, this should be a negative 1, I'm sorry, negative 1. Then I have the point negative 1, 0. And then I have the point 2, 2. Oh, I'm sorry. I have the point 0, 1. And I have the point 2, 2. Okay, and again, I'm going to draw a smooth curve to find that graph. Okay, again, I apologize for the video quality. I'm hoping that some of this is making sense. If we look at this domain, hopefully you can see it goes from negative 2 to infinity. My range is all real numbers, so negative infinity to infinity. My intercept is occurring at 0, 1. And actually at negative 1, 0. Okay, here's my x-intercept, here's my y-intercept, and my asymptote now is occurring at x equals negative 2. Excuse me. So again, I apologize for the video quality. If you have any questions, please let me know in office hours. Pause whenever you need to. Go back and watch the video. Maybe some things will become clearer. Ask your friends for help. Your book, section 3.2, can also be a huge resource. Okay, so we've gotten through about half of our notes. So if you could come back and watch the other video, I'd appreciate it.